This lesson isn't anything new. It's just about if I gave you a polynomial of any sort, do you know how to factor it? So we're going to cover factoring completely using all the methods we've learned so far. So the first thing I want to do is I want to go through a thought process that you should be going over in order to factor. So I give you a polynomial. There's kind of a flow chart you should follow. The first thing you should always do is look for a GCF. Always, 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 always take out a GCF first if there is one. No matter what type of polynomial it is, take out the GCF. So you're going to factor it out. After that, you should then look, do I have a binomial? Remember, that's two terms. Do I have a trinomial? That's three terms. Or do I have a polynomial? And we're just going to classify this right now as four terms. So you've learned a couple different methods to solve. If you see that it's a binomial, two terms, you're going to look, is it a difference of two squares? Is it a squared minus b squared? If it is, factor it. If it's not, you're done. If you have a polynomial, four terms, you're going to factor by grouping. That was yesterday's lesson. You're going to write the first two terms into binomials and the second two terms into a binomial, take out the GCF of each binomial, and then have one factor be the common binomial and the other factor be the remaining GCFs. If it's a trinomial, you're going to be using the x squared minus bx. Well, I'm going to write ax squared minus or plus bx plus c. Right now, we've only learned when a is 1. We are going to learn when a is not 1 starting tomorrow. But in this, you're looking for the factors of c that add to b. So this has covered everything that we've learned so far. But it is a thought process. You have to remember these methods, and you have to think about them when trying to figure out which one to use. So we're going to go through a couple examples just to kind of help you go through that thought process. All right, looking at this first example, we're going to look and first see, is there a GCF? There is not a GCF, so we can't do anything about it. So we're then going to look, is it 2, 3, or 4 terms? This is 3 terms. A is 1, because this is A. So A is 1. And I'm going to look for the factors of 6 that add to 5. Well, remember, it's positive, so I can do 1 and 6, or -1 and -6, or 2 and 3, or -2 and -3. Well, I'm going to see that 3 and 2 actually add up to 5. So those are my factors, x plus 2 times x plus 3. And I'm done. That's my final answer. All right, given x squared minus 16y squared. Again, I'm going to look, is there a GCF? No, there's not. Is it 2, 3, or 4 terms? It's 2 terms. So I'm going to factor a binomial. Is it a difference of squares? Well, x is being squared. It is a minus sign. And here I have 4 squared and y squared. So these are my a and my b. X is my a, 4y is my b. And I'm given x plus 4y times x minus 4y. And this is my fully factored form. All right, looking at this example, I see 3x squared minus 9x minus 30. My first thing is there a GCF? In this case, there actually is. I can take out a 3, and I'm left with x squared minus 3x minus 10. Look at how much easier that made my new polynomial. So I'm now going to look and see if I can factor that. But don't lose the 3 on the outside. That needs to stay there in your final answer. So I see that it's a trinomial, so I'm going to look for factors of negative 10 that add to negative 3. Well, because it's negative, I have to have a positive and a negative. So I can do 10 and 1, but I know that's not going to work. So I can do 5 and negative 3, or negative 5 and positive 3. Oh, excuse me, not 3. Sorry, 5 and negative 2, or negative 5 and positive 2. Since I want negative 3, negative 5 plus 2 is negative 3. These are my factors. So I'm going to leave that 3 on the outside, and I'm going to have x minus 5 times x plus 2. And that's my final answer. I want you to pause the video and try this one on your own. All right, hopefully you went first, look for a GCF. We see that there is a GCF. It's 4, and I'm left with x squared minus 1. Then you should have thought, well, I see 2 terms. Is it a difference of squares? It is. So I'm going to have 4 times x plus 1 times x minus 1. Hopefully you didn't lose this 4 on the outside. That needs to stay there, and this is your final answer. Pause the video again and try this one. All right, we have negative 2x squared minus 4x minus 2. The first thing you should think of is there a GCF? And remember, I always said if the first term has a negative, pull out a negative. So negative 2, and I'm left with x squared plus 2x, because negative 2 times positive 2 is negative 4, plus 1. Now I'm going to look for what factors of 1 add to 2. Well, I have 1 and 1, or negative 1 and negative 1. Hopefully you said 1 and 1, so I'm left with negative 2 times x plus 1 times x plus 1. If we want to simplify this further, we can see that these 2 terms are exactly the same. Therefore, the truly simplified answer to this is negative 2 times x plus 1 squared. But both answers are the same, although this is the most simplified version. Pause the video and try this problem on your own. Okay, looking at it, you should have first gone, is there a GCF? No, there's not. So then, is it 2, 3, or 4 terms? It is a binomial, so it is 2 terms. So is it a difference of 2 squares? Well, I see that I have x being squared and 6 being squared. But is it a difference? Because of this plus sign, and we've seen this problem before in class, it is not a difference of 2 perfect squares, and therefore the answer is prime. Again, pause the video. This is our last example. Pause the video and try this one on your own. Okay, we have x squared minus x minus 72. Is there a GCF? No, there's not. So is it 2, 3, or 4 terms? It's a trinomial, so we're going to look for factors of negative 72 that add to negative 1. 72 is a really large number. We don't want to write out all the factors. We know that we need our 2 factors to be similar in number. They need to be actually 1 off of each other in order to get the sum to be negative 1. So let's think of larger numbers that divide to give you 72. My first instinct is to go to things like 6, 7, 8, 9, 10. Obviously 10 doesn't go in. 6 does. So looking at 6, we have 6 and 12. So 6 and negative 12, or negative 6 and 12. Is that going to add to negative 1? No. Does 7 go into 72? No. Does 8? Yes. 8 and negative 9, or negative 9 and 8. Since we want it to be negative 1, oh, I just wrote the same thing. I'm so sorry. 8 and negative 9, or negative 8 and positive 9. Since we want it to be negative 1, this is the one we want. So we're going to have x plus 8 times x minus 9. If you don't understand how I went straight to this answer, write out all the factors of 72. It will take you a little bit longer, but it's better to take longer and get the right answer than to not get the right answer at all. And that's factoring completely using all the methods we've learned so far.